Welcome to Current Chem World. Good morning. In this video, we'll see what is polarography. It is an electrochemical technique. It is a voltammetric electrochemical technique. What are the terms used in polarography? There are 5 types of currents observed. They are 4 types of currents observed: residual current, migration current, diffusion current, limiting current. Then halfway potential. It is one of the important parameter obtained from polarography. Polarograph. And Ilic equation is used to interpret the polarograph. This is the equation. This equation gives relationship between diffusion current and the concentration of the electroactive species. Okay, first let us see what is polarography. As I said, polarography is nothing but a voltammetric technique of electrochemical method of analysis. It consists of polarisable working microelectrode, that is dropping mercury electrode. This is very important. Polarography consists of dropping mercury electrode. Okay. In voltammetric technique, it is always the current is measured, current flowing through the electrolytic cell is measured as a function of increasing applied potential, applied voltage. Okay, the current flow from the electrolysis of a solution is measured as a function of applied voltage. Next, we will see who invented this polarographic technique. It was invented by Czechoslovak chemist Herovsky in 1922, who was awarded Nobel Prize for this invention in the year 1959. Let us see the experimental setup for this polarographic technique. This is the experimental setup for polarographic technique. As I said, it consists of 2 electrodes. One is microelectrode, capillary tube. Here you have drop. It is not shown here. Okay, and this is the counter electrode. This is a polarizable electrode. This is a non-polarizable electrode, and this is an electrolytic cell. It consists of an electrolytic solution. Okay. Now you see, using battery, the potential is applied to the electrochemical cell using this battery. Okay, 5 volt battery or 10 volt battery. And why variable resistance is used? It is used to gradually increasing the applied potential to the electrolytic cell. It is used to vary the applied potential to the electrolytic cell. Okay, now what is voltmeter? It is used to measure the potential applied. Since we are varying the potential, what is the potential applied at that time to the electrolytic cell? Ammeter is used to measure the current flowing at different potential applied. Okay, so here this is the dropping mercury electrode. It consists of a mercury reservoir from where through capillary tube mercury is falling as drops. Okay, the drops will remain at the tip for 1 to 5 seconds. This is the setup, experimental setup. This is the polarograph obtained by plotting current versus increasing applied potential. Okay. Okay, now this is what I described now. The principle, what is the principle of polarography? Increasing applied voltage is applied between the 2 electrodes. Okay, one is polarizable, another is non-polarizable counter electrode. This is polarizable dropping mercury electrode. The current flowing between the two electrodes is measured using ammeter and plotted, called polarograph. So this is the polarograph. A sigmoidal shaped current voltage curve is obtained. This graph is used to find the diffusion current and half-wave potential. From this polarograph, half-wave potential, this is the half-wave potential. Okay, see, as you increase the applied voltage, there is no significant increase in current, that is residual current. There is only residual current in the beginning. Okay, at some point at a particular voltage, above the particular voltage, there is increase in current flow due to reduction or oxidation of the electroactive species, and then after this point, after this potential, the current remains constant. Okay, this is called limiting current. The difference between the two is called diffusion current, and this is the midpoint of the rising curve. The midpoint of the rising curve, the voltage corresponding to the midpoint of the rising curve is called half-wave potential. Okay, diffusion current is directly proportional to the concentration of the electroactive species. Therefore, it is used for quantitative analysis. Okay, how much copper ion is present, how much organic ketone species, aldehyde species which undergoes reduction is present. Okay, and half-wave potential is characteristic for every substance. It is different for different substances. For copper, it is different potential, deposition potential. For cadmium, it is different deposition potential. For organic compound, so it is used for qualitative analysis, whether what is the metal ion present, what is the organic species present. Okay, what is Ilic equation? This equation is used to analyze the polarograph for interpreting the polaragram. It gives the relation between the diffusion current and the concentration of the electroactive species present in the electrolytic cell. This is given by this equation, ID equal to 607 Nd to the power of m to the power 2 by 3 t to the power 1 by 6. Concentration, C is concentration. Okay, where ID is the diffusion current, is measured in microamperes because of low concentration. Concentration of the species is only in millimoles, not in moles. So it is measured in microamperes. Number of electrons involved, for example, copper 2 plus 2 electron is involved in the electrode reaction. Diffusion coefficient, how much fast it diffuses, centimeter square per second. Weight of the mercury drop flowing, what is the weight of the mercury drop, okay, flowing per second. Drop time, how much time it takes to fall, okay, this is drop time T, and concentration in millimoles per liter. From the polarograph, there are 4 types of currents observed. What are they? They are residual current. Here you see the migration current is actually eliminated by using supporting electrolyte in large excess. Okay, you will see again. Diffusion current, see, this is the difference between residual current and limiting current, and then limiting current. And the important parameter obtained from polarography is half-wave potential, which is characteristics for every substances. Let us see one by one the various currents, the 4 types of currents. The first one is residual current. It is represented by IR. The current that flows in the absence of depolarizer, electroactive species, that is due to the supporting electrolyte, is called residual current. Okay, without electroactive species, only in the presence of supporting electrolyte, okay, that is called residual current. It is useful for analyzing the polarigram. For example, to obtain the diffusion current. Okay, the residual current is the sum of condenser current and Faraday current. This condenser current is due to the formation of Helmholtz double layer at the mercury surface. Helmholtz double layer plus cathode means negative. It is surrounded by cations, copper cations or cadmium cations. Faraday current is due to impurities, okay, because in the absence of depolarizer, because of some impurities, it will give trace current. Okay, the second one is migration current. It is due to the migration of cations from the bulk of the solution towards the cathode due to diffusive force irrespective of concentration gradient. But migration current is eliminated by using supporting electrolyte. For example, KCl is used in large excess, that is 50 millimolar to 100 millimolar. The third important current is diffusion current. This is very important for polarographic analysis or quantitative analysis. Okay, the difference between residual current and limiting current is called diffusion current, ID. The diffusion current is due to concentration gradient. That is important. Diffusion current occurs due to concentration gradient. If there is no concentration gradient, then there will be no diffusion. Okay, so diffusion current is due to the actual diffusion of electro-reducible species or electro-oxidable species from the bulk of the sample to the surface of the dropping mercury electrode. So what is limiting current? It is represented by IL. Beyond, after a certain potential, you see there is residual current first, and at decomposition potential there is a sudden increase in current. After a certain potential, the current reaches a saturation value, steady state value. There is no change in the current flowing. Okay, that is called limiting current. At this point, that is, the rate of diffusion is equal to rate of reduction or rate of oxidation of the electroactive species or analyte. At this state, it is called concentration polarized. The electrode is the state of concentration polarized. The most important parameter obtained from polarography, in addition to diffusion current, half-wave potential. Okay, half-wave potential is the potential at which half of the electroactive species is reduced, half of them is not reduced. Okay, therefore oxidized species is equal to the concentration of oxidized species 50%, concentration of reduced forms 50%. They are equal to each other. In our case, migration current is not observed from the graph, polarograph. Why it is not observed? Because of the role of supporting electrolyte in polarography. In many exams, they will ask what is the role of supporting electrolyte in polarography. So it helps in polarography by increasing the conductivity of the solution, because the electrolyte, the electroanalyte concentration is very small concentration, millimoles per liter. It increases the conductivity of the solution first, then reducing the influence of migration of the electroactive species. Therefore, it eliminates the migration current. Migration, we need only diffusion current, okay, that is directly proportional to the concentration of the species, that occurs due to concentration gradient. That is very important. So we have eliminated migration current. Okay, to accurately calculate the diffusion current for quantitative analysis. Now, what are the advantages of polarographic technique? The surface area is reproducible because the drop is renewed every time. So the electrode is renewed, thus eliminates poisoning effect. Mercury also forms amalgam with the metal atom. For example, cadmium 2 plus is reduced to cadmium metal, it will form amalgam. Okay. The surface area can be calculated from the weight of the drop. Then fifth point, the diffusion current is directly proportional to the concentration of the analyte. Therefore, this is used for quantitative analysis. How much, for example, from the halfway potential, which is characteristic of every species, for every species it is different. Therefore, from the halfway potential, what is the species? For example, copper means it will give, copper 2 plus will give some decomposition potential, deposition potential. Cadmium will give different halfway potential. Sometimes we can simultaneously measure the two species. Okay, qualitatively identify, and quantitative, how much amount of copper is present, how much amount of cadmium is present, can also be determined. If there are advantages, then there are disadvantages. What are the disadvantages of polarographic technique? The capillary is very small. The capillary tube is very small. Thus, it could be blocked due to dust or so. Mercury is very toxic metal. It is neurotoxic. Even in thermometer, it is nowadays not used. Ethanol only used. Surface area of each drop of mercury is never constant because of slight variation in each drop. It cannot be used at a higher oxidative potential because due to the oxidation of mercury. For example, 0 to 2 volt. After 2 volt or so, mercury is getting oxidized. In such cases, rotating platinum electrode is nowadays used. Okay. Thank you for watching. Please share and subscribe. Thank you again.